Selective Catalytic Reduction, or SCR technology, is an after-treatment system that transforms the nitrogen oxide produced during the combustion process into nitrogen and water, which occur naturally in the atmosphere. SCR maximizes engine power and treats exhaust gases with diesel exhaust fluid, also called DEF or AdBlue, to eliminate nitrogen oxide pollutants. SCR technology is used to meet Tier 4A emission standards on Case IH ag equipment over 100 horsepower, such as the Steiger, Magnum, Maxim, and Puma tractors, and the Axial-Flow 5130 to 9230 combines. This TechCom will cover the SCR main components and controller logic, understanding SCR messages and determining what actions, if any, need to be taken, and how to troubleshoot and diagnose SCR faults, including EST functions. The SCR system was introduced in the 2010 TechCom titled Introduction to CNH Tier 4 Emission Solutions. Please review this TechCom for details on the components and operating features of the SCR system. You've completed Section 1, Introduction. The main components of an SCR system include the supply module, which pressurizes and pumps the DEF solution. The supply module consists of the DEF supply pump and filters, as well as the DOX Control Unit, or DCU, a reverting valve, and sensors. The DCU controls and manages the quantity and pressure of the DEF solution using temperature and pressure sensors. The DEF pump delivers the pressurized fluid to a dedicated injection system. The DEF tank stores the DEF solution on the vehicle. It also contains fluid temperature and level sensors, as well as a heating unit for defrosting on some models. The dosing module injects the DEF solution into the mixing chamber, where it's mixed with the exhaust gases. The SCR Catalytic Converter chamber is where the DEF reacts with the catalyst in the chamber. Let's take a closer look at the SCR system sensors. The nitrogen oxide sensor senses the amount of nitrogen oxide leaving the SCR chamber. The humidity sensor is located at the intake air filter. The higher the humidity, the lower the nitrogen oxide production from the engine. This, in turn, provides lower DEF consumption. The urea level and temperature sensors are at the DEF tank. And there are two exhaust temperature sensors, one upstream and one downstream of the catalyst. An SCR system has 12 to 24 volt power converters. On units with a 24 volt capability, 24 volts are supplied from the battery equalizer to the DCU, the coolant control valve, and the nitrogen oxide sensor. Notice there are two CAN buses in the CAN system architecture on SCR machines. CAN 1 and CAN 2. CAN 2 was added for the SCR system's nitrogen oxide sensor. Both CAN 1 and CAN 2 will have CAN high and CAN low signal carrying wires. The CAN high reading should fall between 2.5 to 3.5 volts DC. CAN low should be 1.5 to 2.5 volts DC, and at least 1/10 of a volt lower than CAN high. The CAN bus communication line includes a number of control modules, including the SCR system's DCU, which is also referred to as the DOX Control Unit. Typically, the diagnostic connector for the DCU is the same connector used for the engine diagnostics. The engine controller, or ECU, sends the nitrogen oxide and humidity sensors signals to the DCU via CAN bus. The CAN bus communication line also includes the transmission electronic control module, the display, and the keypad. You've completed Section 2, SCR System Overview. In this section, we explain the main components of an SCR system, as well as the CAN bus system architecture. It's important to be able to know what the SCR system is telling you and whether it's a message for operator awareness or a fault. Messages generally fall into the following three categories: Low DEF level is indicated by an audible alarm and the refill icon. A problem with DEF quality is indicated by an audible alarm and the engine derate icon, followed by the poor DEF quality icon. Displays that can show text will also read poor DEF AdBlue quality detected, torque limitation. A technical failure is indicated by an audible alarm and the technical failure icon, as well as the message DEF AdBlue injection failure, or SCR failure, if equipped with a text display. The messages low exhaust temperature and emission system test in progress are two other messages commonly perceived by operators as a failure, but they are actually normal operation. The way the system deals with these operations depends on the model year software. Understanding the system logic will help with troubleshooting. With the model year 2010 software controller logic, the operator will not see an emission system test in progress or low exhaust temperature message, but will be notified of an SCR failure whenever the system encounters a fault or is running an emissions test. Engine torque and speed may be dramatically reduced. When this occurs, the system allows 3 30-minute restarts, called validation restarts, at full engine speed and engine torque. Once these 3 restarts are used, the unit will shut down after a 2-minute idle time is detected. Then the machine will not restart until the fault has been cleared. The machine will not shut down while moving. The system will look for a minimum 2-minute idle before it will shut the engine down. To determine whether an SCR failure message on a machine with model year 2010 software indicates normal emissions testing or a fault, use the EST and EASY tool to check whether fault codes are logged in the engine controller. Not all fault codes are shown on the display. You can also use the EST to reset the validation restart counter after all 3 have been used. With model year 2011 software, low exhaust temperature on the display does not indicate the temperature sensors are failing. It means the system needs to complete the healing process. Healing is an emissions process in which the SCR system needs to perform an active test to determine the ability of the after-treatment system to control nitrogen oxide emissions, but can't because exhaust temperature is too low. For the after-treatment system to perform this test, the exhaust system, including the catalyst internal to the muffler assembly, needs to be at specific temperature for the chemical reaction to occur properly. The after-treatment system performs the emissions test if there is an SCR system technical failure or poor DEF quality. Here's how it works. The low exhaust temperature or emission system test in progress message will appear on the display. The number on the display indicates how many validation restarts are remaining. If there are no restarts remaining, you'll need to reset the validation restarts with the EST. The emissions test can occur only when a minimum exhaust temperature is reached on both the upstream and the downstream exhaust temperature sensors. You can monitor these temperatures with the EST. To reach the proper exhaust temperature, place the unit under moderate to heavy load, a 30 to 90% load capacity via drawbar load or PTO dynamometer. Some units may be able to be loaded in high gear or placed under large hydraulic load in the remotes, using a flow meter and restriction. For example, a flow of 25 gallons per minute at 2,000 psi will produce about 29 horsepower. This is enough load to build adequate exhaust temperature. Low exhaust temperature should be displayed until the exhaust temperature is reached. Then the message should change to Emissions System Test in Progress. Once the catalyst temperature is reached, the after-treatment system applies 2 types of DEF doses in order to control nitrogen oxide emissions. The first dose is based on an internal logic table, and the second is based on the observations from the nitrogen sensor parts per million output. Continue to load the unit until the Test in Progress message disappears. This indicates the test is finished and passed. The vehicle should return to normal power and operation. You may hear an audible sound when the emissions test message disappears, along with the engine fault 3581 still appearing on the display. If this occurs, return the unit to low idle. The engine fault display should be cleared and the unit will return to normal operation. You can also clear the fault with an engine shutdown for 2 minutes. If an SCR failure message appears, the emissions test did not pass and another fault has occurred. The fault may be different from the original issue. Use the EST and the Easy Diagnostic tool to retrieve any present or non-present diagnostic trouble codes. If emissions system test in progress is still present and the engine derate is present again, the emissions test is not complete and the unit needs continued operation to finish the test. If the engine derate is present, use another validation restart to continue full load operation before the exhaust temperature starts to cool down. Continue operation of the unit after the restart. If the emissions test has run for 30 minutes with no results, you may have exceeded the 30-minute validation restart. When this occurs, shut down the unit. You must get to low idle position and perform another validation restart to continue the test. Some technical failures do not need the active dosing to occur for the SCR system to heal. For these types of failures, you can cycle the key to the off position for a minimum of 2 minutes or run the unit at low idle. The logic has changed with the 2012 SCR software. The machine will not trigger a healing process after a fault has occurred. However, if the same class of fault code occurs 3 times within 40 hours of runtime, the machine will be reduced to low idle and be limited to 30-second emergency restarts. The theory behind this software is that the necessary SCR catalyst temperature will be achieved sometime during 40 hours of runtime to allow an emissions test to occur. Each model year software has different failure classes. For example, for model year 2012, Class 1 is electrical. The engine will be in a state of derate all the time in response to an electrical fault. The system will not need active dosing for a Class 1 fault. Class 2 is hydraulic pressure may not be seen, but on the next key cycle, it can be seen. The system will not need active dosing for a Class 2 fault. Class 3 is the emissions test. The system will need active dosing and full system functionality to clear this fault. Not all classes of failures are displayed as fault codes on the display. Use the EST and the Easy tool to view fault codes and observe how the system is operating on key cycle to troubleshoot effectively. So, if a machine has 3 Class 3 failures in 1 hour, it will be locked at low idle. If a machine has 2 Class 3 failures and 1 Class 1 failure, it will not be locked at low idle. Each class has its own timer and resets after 40 hours has passed without any similar class failures. With the model year 2012 software, emergency restarts allow 30 seconds of operation without engine speed or engine torque limits. After 30 seconds, the engine speed will go to low idle. There's no limit on the number of emergency restarts. During emergency restarts, the display will indicate the number of seconds remaining before low idle condition occurs. The after treatment system will automatically reset for an SCR system technical failure or poor DEF quality after a key cycle. This means at key cycle, the vehicle will run normally with no warnings or messages. The timer is not reset, only monitored. While technical failures, including poor DEF quality, are reset automatically during a key cycle, the failure or derate will not be present at the next key on cycle. Normal operation will resume. Some technical failures will not automatically reset after a key cycle. This type of failure, such as shorted electrical wiring, needs to be repaired. Remember, if the same failure as the initial failure is redetected within a 40-hour period, the last active derate will be resumed at the same strength level and timing as the previous detection. You've completed Section 3, SCR Display Messages. In this section, we explain the 3 categories of SCR messages: low DEF level, DEF quality, and technical failure. We also explained how the model year 2010, 2011, and 2012 software handles low exhaust temperature and emission system test in progress operations. In this section, we'll look at the causes of and solutions for some common SCR fault codes. However, combines have a unique set of fault codes, which usually begin with the letter E. Please refer to the appropriate manuals for these fault codes. If you see SCR fault code 19298, the DCU is unable to build adequate pressure. Fault code 19813 indicates the pressure in the system was lost during operation. The solution for both is to use the EST to perform the Urea Dosing System Test, or UDST, and confirm the system pressure is to spec. You can view system pressure with the EST when the vehicle is in operation. Compare the UDST graph generated during testing with a known good test found in the EST-UDST test procedure. If the pressures are not within specification, inspect the inline filter in the hose assembly for plugging and debris. Check the general integrity of the DEF delivery system, including the suction tube, lines, filters, etc. If you find debris on the tank side of the filter, which is the side with the pull tab, drain and flush the DEF tank and lines to remove the debris. For instructions, search Assist Knowledge for the symptom. DEF AdBlue tank becomes contaminated. Fault code 19325 indicates the DEF tank temperature is too high. The most common cause of this fault is the coolant control valve hoses have been swapped, or the coolant control valve is not sealing properly to shut off coolant flow, causing the DEF tank to overheat. Correcting either condition will remove this fault. Fault code 3158 is specific to the Tier 4 anti-tamper feature when incorrect engine software is installed to generate increased horsepower. It's defined as invalid ECM checksum. This code can appear after downloading software to the ECU or specific vehicle controller. Use the configuration icon on the EST to perform the engine dataset registration. This syncs the vehicle and engine controllers. Allow the engine to run for 5 minutes to register the downloaded dataset before keying off. You may still see this fault code if you key off and on before this process is complete. A message to register the dataset, if it has been changed, will occasionally appear on the EST after downloading software. If the procedure to register the dataset has been completed, the machine needs to run for 5 minutes to complete the registration process between machine modules. Once the machine runs for 5 minutes, the fault can go inactive or non-present. Once this occurs, the fault code can be cleared and should not appear again. If the fault does appear again, run the machine an additional 5 minutes to ensure the fault does not reoccur. If fault code 3581 appears, the unit is currently in a performance limitation due to a failure in the SCR after treatment system. The display may also show SCR failure. This fault code is for information purposes only and is logged as a secondary to all faults that have a derate applied. Use the EST and the EASY tool to retrieve the DTC faults from the ECU and the DCU. These are helpful in determining the root cause. Engine fault 3611 indicates the catalyst efficiency is below level number 1 threshold limits. Engine fault 3612 may follow 3611 and indicates catalyst efficiency is below the level number 2 threshold limits. Catalyst efficiency issues may develop if the current load is lighter than the previous load and exhaust temperatures are not hot enough. As the catalyst cools down, the efficiency drops because heat is a primary factor in nitrogen oxide conversion. This decrease in performance can indicate an efficiency fault. To determine the cause, remove the dosing module and inspect it for large amounts of scale buildup. You'll observe some scale on the injector tip, which is normal. Then inspect the mixer down in the tube after the dosing module. Verify this is not built up with scale, which will prevent it from mixing the vaporized DEF properly. Also, check the DEF concentration with a refractometer if you have that capability. The perfect mix is 32.5% urea to 67.5% water. Then, place the unit on the dynamometer to heat the exhaust. Then watch the nitrogen oxide sensor output in the Derate status screen on the EST. You should observe a drop from the static 500 ppm to 200 ppm or lower. You can compare this to the estimated NOx output from the engine, which is also found in the lower portion of the Derate status screen. Please note that with some EST software versions, you cannot access the Derate status to monitor the nitrogen oxide output on the Cursor 13 two-stage turbocharger engines. Nitrogen oxide sensor in-range failures can also cause the 3611 and 3612 faults. Swapping with a known good sensor or replacing the sensor can verify the sensor plausibility. You can also place the NOx sensor in the dosing module hole to verify the sensor is working within reason. View readings from the EST Derate status screen. Refer to the TechCom reference manual for expanded values or reference assist. Also remove the exhaust pipe and inspect the catalyst substrate for damage and cracking. The substrate should be a uniform honeycomb structure. If cracking is present, replace the SCR chamber. Finally, if the unit is equipped with model year 2010 or 2011 software, you can update the software to the model year 2012 version, which may help with erroneous 3611 and 3612 fault codes due to some improvements with the detection. If you update the ECU software, the ICU software also needs to be updated to be compatible with the ECU. This will change how the operator observes and detects failures within the after-treatment system. Be advised, once the change has been made, you cannot reverse it. Now let's troubleshoot some common complaints. If the operator complains of low power during vehicle warm-up when the ambient temperatures are below freezing, look for dealer-only viewable fault code 1A8 and/or diagnostic trouble code 59D. The dosing module is cooled by a constant DEF flow to protect the nozzle tip against overheating. There are two possible situations that can lead to a stop of the dosing module cooling. The first is defreezing of the DOX system, or DEF in tank is frozen, no DEF circulation. There is the 30-minute defreezing mode that the DOX system performs when the DEF in the tank is frozen and there's no DEF circulation. This is normal operation. If the DEF is frozen due to low temperatures and you do not wish to wait for defrosting via the internal heating element, park the machine in a heated garage to defrost the solution. Protection of the dosing module will prevent overheating when no DEF flow is present, either from technical failure or defreezing mode. The second situation is when there is a DOX system technical failure, such as a DEF pump defect, or there are plugged filters, crimped lines, or air entering the suction side of the DEF inlet supply line. SCR chamber concerns, primarily in cursor engines, occur when low combustion temperatures from lack of engine load and long idle times cause excessive sooting and hydrocarbon buildup within the catalyst muffler's substrate. To correct this concern, clean the catalyst substrate to prevent internal damage. This is a manual procedure and will not automatically occur. To clean the catalyst substrate of any hydrocarbon buildup, place the unit under heavy load for 25 minutes every 6 hours. Any work that will generate a minimum exhaust temperature of 220 degrees Celsius for 25 minutes is required to clean the catalyst substrate of hydrocarbon buildup. Monitor the upstream and downstream exhaust temperatures during the cleanup procedure to ensure the minimum exhaust temperature and active urea dosing are achieved to effectively clean the substrate. After this cleaning procedure has been performed, the unit can be returned to an extended low idle period of work. If the after-treatment system malfunctions after a service procedure, keep in mind that the after-treatment components contain internal components that can stick or fail if the DEF dries and/or crystallizes from being open to the atmosphere during service work. The dosing module is also highly sensitive. The internal check valve components, when stuck open or closed, do not allow the system to build pressure or evacuate properly. Poor evacuation leaves liquid DEF in the lines, which can possibly freeze in cold climates. A check valve that is stuck open will cause low depth supply pressure. To prevent these types of malfunctions, tightly cap all open ports when servicing the after-treatment system to prevent depth evaporation and the formation of crystallization. This includes the supply and dosing modules, any supply and return hoses disconnected from the modules, and fittings at the depth tank. Failure to tightly cap these components can cause plugging of ports, followed by operational problems after the systems are reconnected and placed back into service. The next concern applies to units with the model year 2010 and 2011 software only. If the humidity sensor is not connected correctly during assembly, or for other reasons, the operator will experience low power during the warm-up auto defrost cycle. The default relative humidity will indicate 94%, and the default ambient air temperature will be -13 degrees Celsius. This condition did not generate a fault at the display for model year 2010 and 2011. However, model year 2012 engine software will correct this issue, so a disconnected humidity sensor will now generate a fault and appear on the display. The depth tank vent can become clogged if depth tanks are overfilled by non-automated methods, such as bulk tanks or small jugs. Overfilling allows liquid depth to backfeed into the vent line, which then crystallizes and plugs the vent line. The depth storage tank is vented to the atmosphere. The vent hose does not have any restrictions, such as a vent cap or filter element, which are common in vent hoses for fuel tanks. This is to prevent crystallization of the depth in the vent line. Automatic filling equipment prevents the vent from clogging. If filling manually, do not overfill. DEF requires 7% expansion volume when freezing. Four-wheel drive vent lines no longer use the vent in the urea level temp sensor. You can prevent damage to the exhaust and SCR system sensors by using care when servicing the sensors. Keep in mind that the SCR system's 2 exhaust and nitrogen oxide sensors are sensitive to harsh vibrations and can fail if subjected to these conditions. New temperature and nitrogen oxide sensors have internal wax to protect the ceramic structure during shipment and assembly. Once the vehicle is run, the wax melts from exhaust heat. This results in increased sensitivity to abusive handling, over and above normal engine operating characteristics. You can damage the sensors by removing or installing them with an impact wrench, or working on the exhaust system with a hammer in close proximity to the sensors. Use caution and use hand tools only to remove and install the sensors. And when performing other repairs in close proximity to the sensors, avoid dropping sensors during any handling operation. The sensor assemblies must not contact anything within the exhaust system. Do not use any lubrication when installing the sensors, and do not use any penetrating oil for removal of the sensors, or sensor poisoning can occur. You've completed Section 4, SCR System Troubleshooting and Diagnostics. In this section, we looked at the causes of and solutions for some common SCR fault codes, and how to troubleshoot and correct some common SCR system complaints. You can use the Electronic Service Tool, or EST, to perform many functions with the SCR system. With the EST connected to the CAN diagnostic connector, you can select the monitor icon to see controller parameter information in a real-time display. Choose Change Parameter Selections. To add parameters, select one parameter, then press the Add button. Repeat this until you've added all the parameters you want to monitor. Select Exit when you've selected all your parameters. You'll see real-time data for the parameters you've chosen. The EST version 7 and higher has an engine derate status feature to help diagnose sensors, low power, or observe general items with the SCR system or engine function. The Derate Status tool lets you view the current state or level of derate the engine is providing. This is for information only and does not determine a failure is present. This is the only tool available to monitor the nitrogen oxide sensor output. However, it's not available for the Cursor 13-liter two-stage turbocharged engine. To use the engine derate status feature, select the configuration icon at the top of the EST screen. Left-click to highlight engine derate status on the configuration item selection screen. Then press the Configure Selected Item button. You'll see the main engine derate status screen. If nothing is displayed, select Retrieve Controller Data to refresh the status. Active derates will be present and may not necessarily indicate a failure has occurred. You might see the message, Smoke Map Limitation during acceleration from low to high idle. This is considered normal and does not indicate a failure. Select Exit to return to the EST configuration item selection screen. You'll also find the Engine Restart Counter Reset feature under the configuration icon. This feature is only used on units with model year 2010 and 2011 software. One reset allows 3 additional restarts where the unit can operate for 30 minutes with full engine speed and torque. Then press the Reset Engine Restart Counter button. The EST displays a confirmation that you want to reset the engine restart counter. Select OK to continue. The EST performs the reset automatically, and you see a message if the reset is successful. Select Exit to return to the EST configuration item selection screen. Sometimes the system will reject the request once and then accept the reset request a few seconds later. This is considered normal. Now, let's take a look at the EST controller tests. These tests are used for the Tier 4 SCR system service and diagnostic troubleshooting. The Urea Dosing System Test, or UDST, checks whether the dosing system components are functioning and installed correctly. The test will provide a visual graph and text document describing the pressures, speeds, and operation of the components during the test. The UDST cannot detect if the correct amount of urea is being injected or if the SCR catalyst is working correctly. Before we run the UDST, let's review some important guidelines. If you're going to run multiple UDSTs in a row before running the UDST, take the doser out of the exhaust tube and spray into a bowl to avoid introducing too much DEF and fouling the catalyst. The EST calls out a maximum of 5 tests before heating the exhaust system to burn away collected DEF fluid. In combines with long exhaust runs, CNH suggests removing the dosing nozzle to avoid fluid moving both toward the turbocharger as well as the catalyst. The UDST should be run as a static test with the engine not running. Other conditions that need to be considered to provide accurate and reliable test results include urea tank temperature greater than 5 degrees Celsius, adequate battery voltage, no fault codes logged for the DCU power supplies or internal pressure sensors, actuators, or pumps, and sufficient DEF storage tank level. To perform the UDST with the EST, stop the engine, turn the key switch to on, and select the controller test icon at the top of the EST screen. Select Urea Dosing System Test on the controller test screen and press Start Test. Press Start Test again on the UDST screen. Wait for the routine to finish. The routine will require approximately 3 minutes to run. There are 5 tests, and each test will have a minimum test value or maximum test value that can either pass or fail. Press Abort if you're required to halt the routine and turn off the Urea System device commands. When the test is complete, the EST will display pass or fail at the bottom of the screen. Each line within the graph represents a speed, pressure, or duty cycle. Press the Troubleshoot button to see details about resolving issues. Press Save Data to File to store the test results to a file for sharing data with CNH. Saving the data to a file lets you observe each test in a text document. The text document and graphs can be very useful for troubleshooting the system when a specific portion of the test fails. The UDST can pass but still have a failure. It's important to compare graphs. Do not run the UDST more than 5 times while testing, because urea can accumulate on the catalyst and cause damage. To burn off the urea, run the engine at rated power for 15 minutes, or make sure the upstream SCR temperature reaches more than 350 degrees Celsius for several minutes. The Urea System Flushing and Cleaning routine is used to circulate fluid through the urea lines without injecting urea. This routine can be used to clean the urea lines, especially after disassembling the system. With the engine stopped and the key switch on, select the Urea System Flushing and Cleaning routine on the controller test screen. Flush the system for at least 2 to 4 minutes. This routine will run until you press stop. A typical trace will look similar to this. The urea pressure must be approximately 5,000 millibar. If the trace is significantly different than this reference trace, run the Urea Dosing System Test and follow the UDST troubleshooting to resolve the issue. You must run the Urea System Emptying routine after running a flushing test, since it does not evacuate the system. The DCU will purge the DEF fluid from the system every time the ignition key switch is turned to the off position. The Urea System Emptying routine simulates this occurrence and checks for proper operation. This is not a test. The Urea System Emptying routine can be used to verify that the SCR system is properly purging the DEF fluid from the system. It can also be used to check for leaks in the system, because the pressure of the DEF fluid must drop during the evacuation process. A typical trace will look like this. If the trace is significantly different than this reference trace, run the Urea Dosing System Test and follow the UDST troubleshooting to resolve the issue. Remember, you can always view Assist Knowledge information with the EST for further offline troubleshooting assistance. You've completed Section 5, EST Functions and the SCR System. In this section, we looked at how to use the monitor icon to see controller parameter information in a real-time display, the configuration icon for engine derate status and engine restart counter reset, and the controller test for SCR system service and diagnostic troubleshooting. If you've completed all the topics on the main menu, you've completed this TechCom. Don't forget to take the Technician Recognition Test in your TechCom reference manual and take advantage of the benefits of submitting your test answers online through Web University.